Alright everyone, it's nice to see you guys again. It is yet again recording day on another week. I hope you enjoyed my last video, or this week's video rather. I know you guys enjoyed the one before because I saw all those comments. It's so nice to see so many people like coming in and just watching videos from all over the states. I'm hoping maybe one day I'll be able to get international viewers as well, just because I'm intrigued to see what kind of, or rather to hear what kind of rocks you guys have in your environments. You know, it is a goal of mine to collect a rock from every natural environment that contains them. So yeah, I just kind of want to start by collecting ideas of what to expect when I go to those places. So yeah, don't be afraid to subscribe, leave a comment, let me know, what you see when you're around. If any rocks that you've collected are really interesting and you know what they are, rather you have some characteristics that you want to describe, to go ahead and check with everyone else in the comments or even with me. I would also listen. I will always support rock ID in any comment thread. You never have to worry about me being like, you guys should focus on the video. This is focusing on the video. You're locking in because you're already starting to think like a geologist. So without further ado, I am a little chatty today. I just had a really good lunch with a friend, and all I have to say is, it is the first time that I found a place that I feel like I could eat multiple times and not get tired of the food, and the vibe is immaculate, but that's besides the point. So yeah, here we go. We're going to start with rock ID. Remember, like I said, this is pretty much my last rock ID video until I start collecting more, in which case I'll just kind of sporadically sprinkle them in here when I get, like, here and there when I get enough rocks from my new ventures. But for now, this is the end, and it does include a few rocks that I picked up recently, so I didn't want to leave them out. So rather than 10, we have 12 this time. These are all the rocks, as you can see. Some of they kind of vary in size. Most of them are pretty small. There's a few big ones. And there's medium-sized ones. So they kind of vary, as I said. So yeah, this is number one. Number one is just basically shale with a little bit of spice because it's calcium-bearing shale. Kind of lost my train of thought. So basically, one of the last comments that one of the comments from my last video asked about my process of IDing. Like, how do I ID, what steps do I follow, what do I use, etc. So I am actually going to be uploading a video of how I do that, though it is recorded on phone, because I just don't think that this camera is going to be very good at helping me to actually show you close up how I do things. Although it turns out the phone camera isn't that good at focusing either, but it is better than this one, at least. This one is more for this kind of chatty, sit down with me or come with me where I'm going. Like, it's a GoPro, so it does what it does. It does what it can, essentially, but it can't do that much in terms of detailed videography. Videoing? I don't know what I'm trying to say here, but you know what I mean. But yeah, so I will be basically uploading that video probably later in the week, maybe on the same day, who knows, if my editor's feeling is spicy. I very much doubt it will be the same day though, he's very busy. So basically I did show how I ID'd this rock, how I ID'd number 2, and how I ID'd number 4 in that video. Like, I showed a detailed run by run, but essentially I'm running the same test on all of them. I'm just only showing 3 because I don't want to basically create 2 videos for the same rocks at the same length, or even longer for the actual IDing part. The IDing part takes me an hour, up to an hour and a half, depending on how complex the rocks are. And, a lot of researching, a lot of this is what this rock does, and then I kind of Google it, see, hey, does it seem like sometimes I don't even Google it because I'm like, I just know what it is. I know that I know. Other times, I do Google it for a little help because some rocks are easily confused with others. Now, this is not something I necessarily recommend doing unless you're going on specific threads that help you IDing rocks, because especially if don't just go off of the AI response, because sometimes it can lead you in the right direction, maybe. Other times it can lead you in a mis-IDing direction, which is why I really need to run a professional test on that piece of rock that I think could have gold ore. I kind of have more experience as a geologist, so I can tell when something doesn't make sense. However, for newbies, like, amateurs, people who are just starting out and don't have the proper experience or schooling, AI could lead you astray, so that's just my PSA. I'm not saying I totally hate AI, I'm just saying be careful how you use it, you know? But yeah, anyway, so this rock that I do show the ID process in the later video. Sorry, I'm totally distracted all over the place. So yeah, this guy is scratched by copper. So copper is around like a 2 on the hardness scale. So if a rock is scratched by copper, it is extremely soft. In fact, from what I can recall, no, actually, that's another rock. I won't even go there. Scratch any of that. So yeah, it leaves a black streak on a streak plate. I'm only including all these specific characteristics, so since I included in the other video, maybe I won't do that for these rocks actually, because you guys don't need to hear all those details. You probably don't want to anyways. Those who do, go to the other video. But in any case, so my guess was kind of that it was coming to a limestone, right? At first, that's what I was thinking, because, it fizzes with vinegar, it's really soft. But then I realized something. It leaves a white streak. Limestone doesn't leave a white streak, but shale does. So I kind of was thinking, and also it looks like shale. Let me hold it up to you guys. You see that little like layered stuff that's going on there? Yeah, that's straight up shale in appearance. That's why I picked up this rock when I was on my walk and I was immediately like, yeah, that's shale. But for some reason it fizzes with vinegar, so I'm assuming that it's calcium bearing, or calcareous as they call it. I don't know if that's how they actually say it. I can't remember. But listen, my pronunciations are going to be off. Never expect me to pronounce a lot of English words correctly. And it's not because I don't know English that well. I'm one of those people that when I see something spelled out, I just kind of assume that it's pronounced a certain way because it makes the most sense to my brain. And that's how I pronounce it. And I hardly ever realize that that's not how it's properly said until like much later in life. And I am too old to be changing the way I pronounce things now. So yeah, just so you know, that's gonna happen a lot. But yeah, so it has the same like hardness, shale and limestone. They kind of have the same hardness, but the difference in streaks from what you expect might be due to a manganese oxide. It could also be because of the calcium. Any number of things. Because remember, shales are not specifically. Remember, I didn't explain this in this video yet. I explained in the other video. I got confused because I filmed the ID specifics video before I filmed this. So, as I'm going to explain to you now, shale is not made up of one specific composition of rock. Shale is just the name for a sedimentary rock because of the way that it comes together, the grain composition, that sort of thing. So this, knowing that it's a shale doesn't tell you necessarily what it's made out of. It could have calcium in it, probably because of the fizzing on the surface. It could have manganese oxide. It could have any number of things in it, but it definitely has calcium, at least on the surface. So yeah, calcareous shale. Hopefully I won't take that long for every single rock. I just got kind of carried away for this one. So, this is number 2. This is basically just dolostone. So, basically, I'm going to explain it very quickly because, I don't necessarily want to go through the entire process again. In the other video, I do show it. But essentially, so, there's a such thing as calcium and dolomite are like the two, I can't remember exactly what it's called, CaCO3. Like, that's the scientific name, or like, I can't remember exactly what, but it's the wow, words are hard. So yeah, basically the composition is calcium and carbonate. That's what it's made out of. But dolomite also has magnesium in it, so it kind of reacts differently. It does still react to acid, but only if you powder it first. And what that essentially means is that calcium will react to acid if you just drop it on the surface. It'll immediately react. Now, if you drop it on the surface and it doesn't do anything, that doesn't necessarily mean that there's no calcium in it. It might just mean that it has dolomite instead. Or aragonite, which is another form that I think I've mentioned in another video. It's like basically turning into calcium if it's aragonite. And that has different characteristics to look for. But in this case, dolomite, if you scratch it with something that is harder than it, like, for example, an iron nail. I don't know where I put it. So if you scratch it with an iron nail, for example, and then you drop acid or vinegar on the streak, like on the powder that came off, and that fizzes, then you're looking at dolomite. And in this case, I would say this is a dolostone, probably just it, because dolostones tend to have these little white streaks of dolomite as well. So yeah, that makes sense. I thought it might be two different composition rocks. Like the gray could be some type of either like some type of limestone, and the white could be quartz or calcite as well. But then I actually started to run the test, and no, I think this whole thing is dolostone because the white streaks have the same reaction to vinegar in the same way that the gray part does. So, dolostone. All right, that's number 2 out of the way. Number 3. Number 3 is kind of cool, but that's only because I don't think I have any other sample of this. Not that I don't have any other samples of feldspar, I just don't think I have any other examples of, like, feldspar in this way, necessarily. Oh no, this is not feldspar. Scratch all that. I was wrong. This is what happens when you talk without looking at your nose. So yeah, this is like a pinkish, greenish appearance. I'm going to show you guys. And these are characteristic colors, by the way. So put an asterisk next to that. Remember that ham, alright? That little clue tells us what it is, because some rocks, I think I explained in a much earlier video, you can't really be like led astray by the appearance of a rock because it might not tell you anything about the rock's composition, especially if you're looking at a weathered surface. However, in some cases, certain rocks have such a characteristic appearance or characteristic combination of colors that it actually does tell you something about the composition of the rocks. You just kind of have to get used to knowing what to look for. And also, it helps to know the general history of your region to know if it even makes sense to be thinking that. You're probably not going to find metamorphic rocks, for example, or anything that looks like a metamorphic rock at the surface in, say, like, the West, the desert. Because, you know, there's definitely been more regional metamorphism in general in this, like, in the United States, but a lot of the regional metamorphism in mountain building has mostly happened on the East Coast. So if you find a random gneiss in the middle of Arizona, either it was transported there by some other source, like a natural source like water, probably not wind, let's be honest. A person could have just thrown the rock out, you know, or it could be something else that just happens to look that way. So that's something to keep in mind. Or, you know, there could be something we don't know about in the geologic history, or that I don't know about, better yet. But yeah, so, you know, it kind of was a long-winded way. You could be uncertain even if you know the geologic history, because you might actually not know as much as you think, like I just demonstrated. But for the most part, if you kind of know what happened there, you kind of know that certain rocks might not make the most sense unless they were transported by a person or something like that. So yeah, it leaves a white streak, it scratches glass, it does, like the nail leaves a shiny residue on it, which basically means that when you scratch it with the nail is weaker or softer than this rock. So it actually leaves some of the residue of itself on the rock, and that's the shiny sheen that you can see on some rocks. And it doesn't fizz. I'll show you guys what the rock looks like now. Hopefully you can see like the pink greenish appearance that I'm talking about. Ooh, no you can't. Because the light is not in a good position. Do you guys mind if I just kind of change that? I've been trying to figure out this lighting thing, and it's a little tricky, honestly. Let's see. Maybe this will work. It's the damn microphone is in the way, honestly. So yeah, anyway, let's see if this works. Yeah, much better, but also a little too close. Ugh, I should probably just leave it where it was. In any case, so yeah, green and pink. I will figure out the lighting situation, don't worry. I'm still learning, though. Hopefully that shows up well. If not, you'll have my photos later to like depend on. So basically, yeah, I think this is actually rhodonite with like banding of manganese oxide. That's my alarm. I need to take those off for future videos. Basically, that alarm is just for me to turn off my snake light, so I'll do that once I'm done here. So yeah, basically this is rhodonite. You know, which rhodonite has the characteristic colors of green and pink. Oh my goodness. Okay. Notes for the future. Turn off alarms. And silence your phone. Goodness gracious. But yeah, so And this is rhodonite, characteristic colors pink and green with little banding of manganese oxide, which is again something that you see in rhodonite. So the rhodonite is the pink stuff, and the green banding that you see all throughout, that's the manganese oxide. So we've got that ID. This guy. This is a really cool little piece. At least I think it's cool. I don't know how valuable people think limonite and goethite and like the oxides are. I like them because I don't have many samples of them. So it's always nice to have like variety, even if it's not always the most valuable, quote unquote, in terms of how much money you can get for them. But I'll tell you a secret. Listen, unless you're trying to go into oil and gas, there's not a whole lot of ways to make a lot of money in the geology field. I'll just let you know that. And honestly, I just didn't feel like, selling my soul, so I did not go into oil and gas. And it has nothing to do with anything else like me being rejected. Not at all. So yeah, this guy, first of all, you gotta see it. It looks like something with a lot of iron staining. The color is like bright orange, yellow, and some spots like mustard yellow, red, that sort of thing. It's very dusty looking. You can kind of rub it and it leaves a residue on your fingers. Very earthy scent. Kind of a pleasant earthy scent though, like not like a sulfur burnt egg or like, something else like that. It's not unpleasant. It just smells like dirt. So you can scratch it with a penny, you can scratch it with your fingernails, so it's extremely soft. And it doesn't have any reaction to vinegar, and it's very light density for, like, this is the size of the rock in general. It's pretty light for its size, in comparison to a similar rock of heavier density, like this one that I just showed you guys. Or that I showed you guys 2 rocks ago, I should say. So yeah, this is limonite / goethite, any one of those types of varieties of, like, oxides and such, and impurities. It's basically, once you get a bunch of those rocks just together, they tend to look like that. So, anyway. 5. This is a rock I picked up recently on one of my walks. Remember how I told you guys I take walks, like I do go hiking, I take walks, and during those times, I try to like kind of glance around to see if I can see anything interesting to pick up, and that's usually when I'll add to my rock collection. Sometimes rocks seem to appear right before me as if God himself was like, hey, this is a pretty neat rock, I think you should, keep it. And then I usually do. I've seen some pretty cool rocks that I've just picked up on my walks, so, Anyway, so this is harder than iron, like it's harder than the iron nail. It does scratch with some effort from a steel knife, but it also scratches the steel itself. It leaves a white streak. It doesn't fizz with acid. And it does have little black specks in it. I think they're pretty interesting. I'm not sure what that is. I don't know if it's even going to show up here. Maybe it'll show up better in the photos. But so yeah, okay, so basically it could be one of 2 things with all those clues that I've given you. It could be a feldspar rock, essentially, or it could be an apatite rock. They're around the same hardness, essentially. Oh wait, actually, they're around like the same. So basically, apatite and feldspar have all the same characteristics I've described so far. The only difference, essentially, is the hardness and the heaviness of the rock. So this rock is feldspars tend to be heavier than apatites. So feldspars and apatites share a lot of characteristics in common. Feldspars are lighter in density though, and they are harder in terms of just hardness than apatite. Because this is harder than apatite and it is lighter, I'm gonna go with the feldspar rock. If I ever get an example of an apatite, I'll show you guys. And that's not appetite like you're hungry, it's APATITE. So, in case you're wondering, because sometimes my pronunciation can be a little hard to understand how someone's pronouncing something in a video. So, anyway, so this guy, this is number 6. This little fellow right here. This is a felsic porphyry, and I am saying it correctly, I think. So basically, this is an igneous rock. So I'll show you guys. I hope that the texture shows up properly, but if you can't see it, basically it's a mixture of mostly smaller crystals with some bigger grains embedded, and they're all kind of mixed up together. So it's got a porphyritic texture. That's what that means. It's just got 2 different grain sizes that are like, I would say, the main grains that you can see. Like, sometimes a rock is made up of just 2 grain sizes, sometimes it's made up of multiple, sometimes it's just made up of 1, and that tells you something about, because it can be made up of just 1 type of grain size, but they're all big, and that would be phaneritic. And if it's made up of 1 type of grain size and they're all small, it's an aphanitic rock. But if it's got both types of grain sizes mixed together, it's a porphyritic rock. It doesn't matter how many different sizes there are. The fact that there's more than 1 grain size already has you leaning towards porphyritic. This is not to be confused with the composition, which can be mafic, felsic, or intermediate. Those are 2 different ways of classifying a rock. An igneous rock as well. So, this resists the knife. It cannot be scratched easily by the knife. It's a very white streak it leaves behind. And it looks very feldspathic, so I was already kind of thinking that it might be a feldspar because of like the pinkish reddish color of it. Typically, if you see that color, it could be an oxide, but could also be feldspar present in the rock. You just have to run all the tests that you could possibly run that it is at your disposal to run. Not disposition, disposal. So yeah, an alkali feldspar basically is the one that tends to show like all the pink stuff, essentially. As opposed to like, you know, a plagioclase feldspar, which is more black and white. It doesn't really tend to have pink in it, but alkali feldspars do. And it's porphyritic, obviously, as I already explained. It's felsic and intermediate kind of in composition because it's lighter and darker stuff in here. But it's still mostly feldspathic because it's got pink. Most of the time, as it starts to get more and more intermediate towards mafic, you lose a lot of feldspar right away because feldspar is not as durable as like other materials. So yeah, this is a felsic porphyry. Really cool rock. 7. I'm sorry I'm going on rambles about different random details, but it seems like you guys like learning, so I'm hoping I'm at least giving you more of an education in geology. A lot of this stuff I learned either really quickly and too quickly to be able to retain a lot of the information, or I learned it very slowly over time, and some things kind of have dropped out over the years since I finished school. There are certain details I don't remember anymore, so that's why I have to Google sometimes to refresh myself. I have to look at diagrams, other rock ID threads. I did take somebody's advice to look into a general mineral club to help me out with IDing and also just to hang out with other rock nerds. It turns out that there's not that many that fit with my schedule though, because I do have baking classes as well and I do orders as well, so it's kind of difficult to socialize when they have only specific meeting times, but there is a promising one that I'm looking into. Hopefully I'll hear back from them because I did email like them to, you know, make sure that the information is still accurate because I don't want to drive more than 15 minutes and then find out that the place isn't even doing meetings anymore. That's just going to be a disappointment. Always check ahead if you can. So yeah, this guy. This has a light streak, not a white streak, it just leaves a lighter streak, it's not black. It is scratched by the knife and by the iron nail. It scratches the glass. It does scratch the steel, interestingly enough, from what I've noticed as well. So there's a variety of hardnesses, which means that it could be that there's something different on the surface that like could be a little softer and that's why it's being scratched by the nail. But if it scratches the steel itself, that means the rock itself is made up of harder stuff. Never be fooled by what's on the surface, I'll tell you that. So there's slight foliation banding. I don't know if you guys can see that. This is where it gets confusing. So for the most part, I'm thinking this is quartzite. Now those of you who know your stuff are probably thinking, but quartzite doesn't have foliation. Sometimes, if certain materials get mixed in with the quartz, and then there's specific, very intense directional pressure, it can still create foliation bands, and it doesn't stop it from being a quartzite. So, yeah. A little something interesting for people who don't know that. Yeah, foliation bands don't tend to show up in quartz-heavy, like, rocks that haven't, like, you know, something like that is not going to become a nice, like a quartz-heavy rock is not going to become a nice because it can't. Quartz is very resistant for the most part. And it will not really kind of bend and do all this cool wavy stuff that other rock materials do under pressure. Sometimes you can get other rocks kind of sewn in that do react to directional pressure. And that's when you see these cool little bands and otherwise, like, I would call it, quotation marks, immovable rocks. So, yeah. Quartzite with some foliation banding. I'm not exactly sure what the dark material is really, but it would be interesting to kind of. It's basically probably just impurities that are in these rocks. Like, impurities basically means it's anything other than what you expect that is mixed into the rock. Something that's not supposed to be there, that is reacting for that reason a lot. Probably the rock, let's say this is like a flat surface. There's just quartzite there. There's quartzite there. And there's some weird impurities in the middle here. And there happens to be pressure along those planes, directional pressure. So then the material that's weaker than the surrounding quartz starts to kind of bend and wave along those pressure planes, creating foliation bands. It's really cool stuff. And also extremely geophysics heavy and stuff like that. So, yeah. Not geophysics, just like very high geology that I don't really feel like getting into right now because I'm kind of tired. But if you guys want like more of an explanation on how metamorphism works, why you see foliation bands in certain things and why you don't see in others, just let me know. This little guy, this is another metamorphic rock. I have quite a few. I think I've said that before, which makes sense. I live in Pennsylvania. Pennsylvania is a very mountainous region, which means that there's been a lot of metamorphism here. So that's what mountains tell you. There's been a lot of metamorphic activity here because there's been a lot of like convergent plate boundary stuff going on here. So that tends to push ground up, or in some cases it pushes, not in some cases, in other cases, like this is the other 50% of what usually happens, barring weird exceptions, you know, or like explainable exceptions, but they can be surprising. But yeah, so it either pushes it up or one of the plates subducts being the other, which usually ends up pushing the one on top up anyways. But yeah, so the plates do come off with like my fingernail. If I just kind of scratch it, I can get the plates off here because these are all mica plates. So mica is a specific type of mineral that the way that its mineral, like the crystal shape is, it's just a flat sheet essentially of like, you know, atom bonds. Those bonds are stronger on the plane of this, like on the I'm gonna try to explain this in the best possible way, and maybe I can put a diagram in here somewhere. But basically, the mineral, like the bond between the minerals together on the sheet is strong, but between sheets as they're stacked, it's really weak bonds. That's why you can scratch a plate off, but it doesn't necessarily break when you take it off the rock. And they're very small too. It's the little shiny stuff that you see in a lot of rocks. It's either the white, the muscovite mica are the lighter micas, and the dark micas are biotite micas. So I think that's the first time I've ever managed to explain why micas are the way that they are. That's really cool. So yeah, basically the plates come off with the nail, but it doesn't scratch easily, which makes sense, you know, because it's a metamorphic rock. This is just basically a muscovite mica schist. And I'll show you the surface that I'm looking at primarily, because once I saw this is the reason I picked it up. I know exactly where I got this from. I got it from the discard pile of the rocks because sometimes students decide or teachers decide that they don't want the rocks that they picked up for any reason. So they have a discard pile at my old university. And basically you can just come and pick one of those rocks up because they'll just put them right outside the door. And then you can see some really cool stuff there. I've probably picked up a few rocks from there. This I definitely remember picking up there. So whoever found this, I would like to know where you got it from, because I have no idea who got it. It was just there one day. So yeah, mica schist. Very shiny, very cool. Now, this is number 9. If you can't tell that I'm tired, I am. About a long day. So yeah, basically this scratches with, like, I think the iron nail is what I meant by that. It is a lot of black and shiny minerals. So I was immediately thinking either it's a hornblende or like some kind of like, what's the other one? Augite. I was thinking it's between augite and hornblende. So I'll show you guys, because those are usually the two usual suspects for the way that this rock looks. Like black shiny minerals that are pretty long and pretty visible. Augite is shorter and stubbier though, and they're not as reflective. Hornblende tends to be much shinier and longer, more rectangular stuff. So that's what makes me think that this is hornblende, because I don't even have to use my lens to kind of see some of these crystal grains, and it is very shiny. So I would think it's more hornblende than augite. And what that is a reference to, or those are igneous rocks, like as well, those are minerals. So that's just a mineral sample essentially. that I completely didn't realize was a mineral sample until I ID it. Because usually I keep the minerals separate from the rocks, or I try to, because minerals tend to be a little easier to lose, a little easier to break than like rock samples are, unless the rock is like very fragile, like a chalk or something. But anyway, so this number 10. This is a siltstone. It is scratched by the knife, but it is different in appearance when it's... Oh, this is one of those cool rocks that you can see the difference in appearance between when it's dry and when it's wet, and I will show that in the photos. It looks a little slightly more interesting when it's wet, but not much more. It's not like the other rock that was very visibly all colors really popping out when you put water on it. This one is not that stark, but it is still an interesting contrast. Now, this is a siltstone, and the reason I say this is because even though you might think that this is a normal, quartz sandstone like most of my other river rocks, most of my river rocks are between siltstone and sandstone, and I may have misidentified some of those in my earlier videos. Generally speaking, a siltstone is even smaller, finer grains than a sandstone, so they can actually come off on your fingers if you rub it a little bit, and that's what this one is doing. Like, you can feel some of it kind of coming off as like a powdery sort of feeling. So, siltstone. Siltstone is just basically one step up, like, in terms of very small grains from like sandstone. It could have the same composition. It might not. It really depends. So this guy is pretty cool. And there is absolutely no way that I'm going to be able to capture its full magnificence on this camera. And it's got basically two different surfaces where you can see the inside. And then it's got this outside weathered like surface. I think I can't remember actually how I got this sample, but I think it must have cracked open on one side and been part of a much bigger rock, like on two sides, that is. Like, it almost looks like a wedge that someone cracked a rock open and then took the wedge out. But yeah, so it leaves a white streak, it scratches glass, it is harder than my knife, and it's a mix of like visible grains of like dark and light material with an overall darker appearance. So my general idea for this is that it's igneous because, I don't know, you can usually tell when a rock is igneous or sedimentary with experience, that is, of course. This one has more of an igneous appearance. All the rock grains are essentially visible, like, and you can see the differences between different rock grains. Remember how I was explaining to you earlier, like, the distribution of like grain sizes in a rock when you're looking at igneous rocks? And there's basically like phaneritic, aphanitic, and porphyritic. So essentially this is phaneritic because even though it's two different compositions, I would say it's like lighter and darker material mixed in, though mostly leaning towards dark, so it's kind of intermediate, but it's mostly mafic. Still, all the grain sizes are pretty much the same. They're all bigger grains you can see with your naked eye, so that makes it phaneritic. So those two factors in conjunction, or I guess in combination, make this a gabbro, in my opinion. I will probably explain to you as well how those different classification systems work for igneous rock if anyone wants it. If not, I will not. It really depends. And now, the last one is much easier to ID. I didn't even really take notes for that because I already knew what it was, because I did identify and show you guys another sample of the same kind of rock in an earlier video. This is basically a garnet wollastonite sample. And I did say, I think in that video, that I had another sample lying around somewhere. Well, I found it, so here you go. Cool stuff. It also does come across and chip, like, it does come off and chip very easily. I don't think it shows up on video, but when I had this on that windowsill for the past week for today's video, literally any movement would have, I think you guys just heard as well, some of the grains falling off. Yeah, very brittle rock. I'll say that much. In any case, so thank you guys for basically coming along with me for the last rock ID video. Next up, I'm hoping to do my gemstones for like next week's video, that is, because I will be, like I said, uploading the video of how I actually identified like my process for IDing rocks, like probably later this week. But next week we're going to move on to IDing gemstones. And I do have a little case of them specifically. And let me see if I can actually show you guys by just moving the camera. I'm not sure how that's gonna. You see that little case? Those are my gemstones. So I have them all together, very neat. You guys don't need to see how much of a mess my room is right now. Anyway, but yeah, so those gemstones are the ones I'm going to be IDing next. I think I'll just do one long video or 2 videos because I don't have as many. I know that it looks like a lot, but they're all pretty small, and IDing like raw minerals and gemstones, or I guess I should say gemstones in that case because they're all polished and they're not raw. None of that is raw. I don't know why I said that. Those are all polished gemstones, and that is much easier to identify than like raw minerals and like sedimentary rocks or metamorphic rocks. So it's not going to take me that long, even though it looks like a lot. I also do collect little gem carved figurines. Like, you know, I have an apple, I think, made out of a agate, and I have this little guy. I like to collect them as well. Like, they're basically made of rock. I may try to figure out what they actually are. I probably should have kept the receipts on each of these because I've been buying them over the years. But, you know, I didn't think that far ahead. So I just thought these look pretty, so I'm going to buy them. Aside from that, after that, we're going to start with fossils. And then any ideas that you guys have for, like, further exploration of certain topics or further explanation. Maybe you want to go on my hikes. Really, it's up to you what you guys want to see. I just wanted to show you guys as much. I just wanted to inform people and basically disseminate information that I already have. So if you guys want to know anything specific and I happen to actually know how to answer it, I will go ahead and do so. If not, I'll research or I'll point you in the right direction. I am not one of those businesses that's like, I don't want to lose numbers by pointing someone elsewhere. My goal here is for you to walk away with more information than you came in with. So anything I can do to help that, I will definitely do so. And in the spirit of that, I'm just going to go ahead and say goodbye to you guys. Thanks for dropping by and stay curious.